Alrighty, how you doing? I'm your man, John Wilson. We're going to finish up Module 6 today. We're going to be working with creating and sketching and identifying graphs and their parts. Specifically, we will understand how to interpret and match graphs as well as sketch graphs given a description. We will then apply this to a real-world scenario and situation. Now, to understand the parts of a graph and what you're being asked from a graph, you have to go all the way back to the 4 types of slope, and you have to remember what they are. So if we look at this first one here, as we move from left to right, the line is going up. If we see this in a situation, we could see indicator words such as rising or increasing. This represents a certain type of slope. What type of slope is it, Alicia? What type of slope is this? That is, in fact, positive slope. That's positive slope, indicated by words like rising, increasing. What about Maldonado? Right here. As I go from left to right, it's going down. Words like falling, decreasing. What type of slope is that? Negative. Negative slope. It's going down. Negative slope. Simple stuff, but you must remember these slopes for what we're going to do next. Fiyama. Fiyama. I have a horizontal line here. Indicator words like stagnant, stationary, unmoving, or constant. Something like that would indicate this type of slope. Fiyama. What is it? Would you like to ask the audience? Adriana?
Is it a zero slope?
It's a zero slope! Ding, ding, ding! Tell her what she's won. She's won nothing except for her ticket. Alright, so yeah, zero slope. But because she called a friend, the friend gets the ticket. It's okay because Fiona actually owns the company that makes the tickets. So, you know, I mean, we all have our parts in life. Anyway, let's go on to Juan Nieto. Last one here, indicator words like infinite, limitless, something like that. What type of slope is the vertical line?
Undefined.
Undefined. That is undefined. So those are the 4 types of slope, and that's going to make up the basics of what we're doing today. For the most part, we'll be working with the first 3. Zero slope, negative slope, and positive slope. Very rarely will you see something that's undefined, because once again, we are talking about real-world scenarios and real-world situations. And pass that over to Maria. Okay, so let's see what this can apply to. We look at this first situation here. We want to interpret what this graph means. The scenario here says a roller coaster park is open from May to October each year, and the graph shows the number of park visitors over its season. That information is as important as this graph is. Why? This piece of information right here, open from May to October, may give you a clue why certain parts of this graph are increasing and why certain parts are decreasing, especially when we think about this in a real-world context. If we look at a graph, and we want to identify or we want to answer questions about this graph, we have to do 3 things. Always read the scenario carefully. That's the main thing. A lot of you know that not reading a question, especially on a test, could cause you to get an answer wrong. Once you've read the scenario, make sure you identify the type of slope or slopes that you are dealing with. Positive, negative, zero, undefined, and then relate the slope to the context of the problem. So read, identify, relate. We look at part A here, and it says, segment 1 shows that attendance during the opening weeks of the park season stayed constant. There's a key word there, constant. Describe what segment 2 shows. So if we look at segment 1, it says it stayed constant, which is true. It was a zero slope. It stayed constant. Did not go up, did not go down. If we look at segment 2 here, what happens in segment 2? It increased. It has a positive slope. That means in the context of this situation that in segment 2, the attendance increased. So the attendance increased. Okay, that one was easy. Attendance increased. It was a straightforward question. The attendance increased. That's what happened in segment 2. And it increased at a pretty decent rate over that month. Keep in mind, it's open from May to October. So it starts in May, that's June, July, August, September, and October. It begins to go down. We have to think about why. Okay, so we go to part B now. We try to get a little more involved in this situation. Based on the time frame, give a possible, there's more than one correct answer, but a possible explanation for the change in attendance represented by segment 2. So what we're looking at here is why the attendance would increase in segment 2. Matthew, do you care to venture a guess as to why the attendance might increase right there?
Because it was June and our kids are not in school at that time.
Beautiful. Because it's June. In June, what happens? All you kids are so happy. You're tearful for about 2 seconds when you're saying goodbye to your friends. Hug, hug, hug. Bye! See ya! Out of here! You see me on social media, I'll be everywhere. Of course, kids are out of school, so when kids are out of school, what happens? They want to go have fun. So, a roller coaster park sounds like a good place to me to go and have some fun. So the kids get in their cars, they beg their parents, they go to the roller coaster park, and that causes my attendance to increase. As we know, you're more likely to see kids at a roller coaster park than a bunch of senior citizens or adults. Why? Because kids like to have fun more than old timers like us. We're all about not having fun and ruining your fun. So, but you're scared of roller coasters? Good, you're already an old soul. You'll live longer that way. All right, so segment 2, a possible explanation. We can say that it is summertime. School's out for summer. Kids out. Kids out. We out, man. We out. We off to the roller coaster park. What happened? Where does it say summer? Okay, so let's think about this explanation. Mr. Veris.
Oh my God.
This is open from May to October. It doesn't say summer. We're trying to give a possible explanation. So segment 1 is May, right? The month of May. Segment 2 is the month of June. What happens in June? And why? What happens? Why are you out? You're out of what?
School.
You're out of kid prison. You're out for the summer. We release you from kid jail. You take off your jail uniform and you're free. You're on probation for the summer. And then somehow you always manage to get roped once again and return here in August, which will come back and play later on. Okay, so summer. Kids are out. They want to go to the roller coaster park. Segment C, which segments of the graph show decreasing attendance and give a possible explanation? Let's go to no name right there. No name. What segments, plural, of this graph are decreasing?
4 and 5.
4 and 5. These segments right here are decreasing, which means that the attendance at the park is going down. So 4 and 5. Do you have a possible explanation as to why the attendance could be decreasing?
Because school starts again.
Because school starts again. So this is May, that's June, that's July, and then here's your least favorite month of the year, August.
Ew.
I'm sure all of you are dreadfully, when summer's happening, looking at that date that you have to go back to school and just looking at it. Tears here, tears here. And then another day goes by. Tears here, tears here. Some of you are like, yes, school's coming back! Woo! Then you wake up, oh my God, that was a nightmare. I had a nightmare. Sometimes I want to go back to school.
Aren't you happy because you make money?
Teachers, I don't get paid. I work for free. I won the Powerball years ago. I'm worth hundreds of millions of dollars. I do this for fun. This is my hobby. I'm worth more than, she has the house right next to mine. It's a huge house. I have a 20 bedrooms, 18 and a half bath, big Wilson compound. On the wrought iron gate, there's a big W. Lots of Dobermans to keep children off my property.
What is my house?
Didn't you say you
Her house is
won the
nothing.
Powerball
Like,
and diamonds and all your money you spent it on the unicorn?
No, no.
Okay, the unicorn now lives in the back of the Wilson compound because I happen to win the Powerball again. And that's another reason math matters. I knew how to pay the Powerball.
Oh, okay. Or you just
No, I bought the unicorn from you the first time I won the Powerball.
What?
Yes.
No, I'm gonna.
Yes,
I'm
you
gonna
sold me the unicorn.
No.
Anyway, so
Yeah, I knew one.
4 and 5 are decreasing because summer is over. Yes! Woo! Tears, tears, and a puddle of tears down here. Frowny face and a puddle of tears. Summer's over. School. Oh.
you should change it to blue.
It's on this page.
So, any questions on interpreting this graph? Yes or no? Any questions?
What else are you gonna put it
Is that
with?
it? Like,
Let's try one more
Because this was the
graph interpretation. We read the scenario. We always read the scenario first. It says in a lab environment, colonies, yes, they have colonies, of bacteria follow a predictable pattern of growth. The graph shows this growth over time. So my x-axis, my input, that's time. My output is the number of microbes, or the number of bacterial microbes. So we want to look at this graph and we want to see what happens to the number of bacteria in this lab over time. We're going to go to Dylon. Dylon, 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 and Dylon. Dylon, what is happening to the population during phase 2? Now phase 2 starts here and ends here. What's happening during phase 2?
It's increasing.
It's increasing by a whole lot or a little or what?
A lot.
It's increasing by a whole lot. That's a pretty steep line. So I'm going to say population is increasing by a lot. By a whole bunch. By billions of bacterial microbes coming to find you where you live. Okay, so yeah, it's increasing. Sibas. Sibas. What is happening to the population during phase 4?
Increasing.
Good. Phase 4 starts here, and now it has started to decrease. As time goes on, everything has a lifespan. It's born, it lives its bacterial life, and then gradually as it gets older, they start to die out. So the bacteria, the number of bacteria start to decrease because the bacteria, they started to move on to the big bacteria roundup in the sky. So during phase 4, population, and I'd say population begins to, because it looks like that's the starting point for the decrease, begins to decrease. Population begins to decrease. Once again, it's just visual stuff. You're identifying what happens during certain segments. And then last but not least, you ready for it? Flash!
Why do you guys do that?
Flash, is this relation linear? Why or why not? Why not? Yeah, the most important part of that, what you said, is it's visual, right? This is definitely not a straight line. This is some weird type of curve here. So no, this is not a linear relation because it does not have a constant rate of change. It increases, 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 starts to get constant and stagnant, then decreases. No constant rate of change, it's not linear, so we can say non-linear, and we could say it's a curved line. Or you could say no constant rate of change. Maybe in parentheses put that no ugly shoes, no croc. No constant rate of change. If it does not have a constant rate of change, it is not linear. Thank you, Flash. There you go. Any questions on this to start off? Any questions? No? Alright, so 4, 3, 2, 1, por favor. The whiteboard are not going to read it carefully and they're going to get it wrong. It's the same exact process. We're going to read the scenario, identify the types of slope, read, identify, and then relate the slope to the context of the problem. Read, identify, relate. What we want to do here is we want to match each student's scenario. We have Jet, Mike, and Grace. We want to match their scenario to the graph that best represents their situation. So let's go to Vivana Magia. Can you read what Jet did?
Jet learned how to spell the same number of words each day.
Okay, so Jet learned how to spell the same number of words each day. When I see this key word right here, same, that means I'm going to have something. That means that I'm going to have some ugly shoes. I'm going to have a constant rate of change if I see this word same. So that leads me to believe that I'm looking for a graph that represents something that is a linear relation. I don't have a constant rate of change. It's going up by the same number, constant rate of change. So I look at these three graphs. Are any of these three graphs representative of a linear situation where you would learn the same words each day? Connor?
Yeah, the first.
Yeah, the first one. If I look at the first one, as time passes, he's learning the same number of words, so his vocabulary word increase. This is a constant rate of change right here, and that is synonymous with the word same. So this is indeed graph A. That's graph A, man. It's just that simple. Thank you, Connor. And thank you, Viviana, for reading it. All right, the next one. Drew, cart left.
Yes, sir.
You have a choice. You can do Mike, or you can do Grace, because once we answer one, we'll know the answer to the other, as long as you do it correct. So who do you want to read, bro? Do you want to read Mike? Do you want to read Grace?
Mike.
Mikey Mike. So what did Mike do? Tell me. Read it loud. Project your
Mike
voice.
started by learning how to spell only a few words each day, but then learned a greater number of words each day.
Okay, so we examined Mike. Mike started by learning how to spell only a few. Okay, so he's still learning, but his increase is not going to be that much. Eventually, he learned a greater number of words each day. So it looks to me like he's learning words. It's going to start out by learning a little bit of a few words, something like this, a few words, and then gradually he learns a greater number of words, so it's going to pick up speed. Do any of the two remaining graphs, cart left, are they representative of that situation, yes or no? B, yeah, B. Starts off learning a few words and then learns a greater amount of each day. That is definitely graph B, and if that's graph B, the only one left would be graph C for Grace, which also makes sense. Grace started by learning how to spell many words each day, so quick increase, but then learned fewer and fewer words each day. So that is representative of, maybe she just learned so many words that there wasn't a lot left to learn. Maybe she learned the first 1,000 pages of the dictionary, and then she slowed down for that last 100, right? Maybe. All right, any questions on this first one? We got a couple more to do. How are you taking your cart left? All right, let's go to Emily. Emily, the graphs below, right here, graph 1, 2, and 3, give the speeds of 3 people who are riding snowmobiles. I want you to tell me which graph corresponds to each situation. So we have Chip, we have Linda, honey, Linda, listen, honey, and Maguli. All right, so we have Chip, Chip. We have Linda, and we have Miguel. Emily, which situation do you want to work with? Chip, Linda, or Miguel? Yes, Emily Tavares?
It's Tavares.
You spell your name backwards, it's Saravat. So Emily Saravat. Saravat. Right, Miss Saravat. Chip, Linda, Miguel. What do you want to work
Miguel.
with? All right, she wants to work with Miguel. Shh. So, please read what Miguel did.
Miguel began his ride by gradually building up speed and then increases at the same speed for a while.
Okay, so Miguel begins his ride by gradually building up speed, and then he just cruises, man. He just drops it back. Puts that arm right there and just cruises. Maybe does some of this. What's that? Little peace sign. Takes a selfie. All right, it cruises at the same speed for a while. So we look at these 3 graphs, and we identify that the y-axis is speed. So if the graph is going up, my speed's increasing. This is time, the x-axis. So as time passes, depending on what's happening, my speed could be going up, my speed could be going down, or my speed could be staying the same. Looking at this, Emily, what graph do you think represents Miguel? Graph 1, let's see. Miguel begins his ride by gradually building up speed. Okay, that works. And then he cruises at the same speed for a while. I agree that that works, so that is indeed graph 1. Thank you very much. Calco! Come on, you have a question? Oh, no. All right, well, let Calco, when I pull you up here, you should be coming soon. And you know, Calco! We got Linda, Chip. Chip, Linda. What do you want to do? Chip or Linda? Linda, honey. Linda, listen, honey. Listen, Linda.
Listen.
All right. What did Linda do?
She increases her speed through the most of her ride, and then she slows down as she nears to some tree.
Okay, so Linda steadily increases her speed through most of her ride, then she slows down as she nears some trees. Okay, so what graph do you think represents that?
Graph 3.
Graph 3. Let's see here. So builds up her speed through most of her ride, then she slows down as she nears some trees, so that she doesn't BAM! Smack right into the trees. Because that would be bad. Linda does not want to slam into the trees. Linda wants to live. So Linda slows down. Just like when you start driving in a couple years. If you see some trees, don't hit the gas. Slow down. Preferably stop. Go around the trees. Live to drive another day. So that is indeed graph number 3, which means that Chip Chop Chip is graph number 2. Yeah, BAM! And then, well, I mean, hey, you know what happens at that point. Fortunately, if you hit a tree doing 60 miles per hour, your odds for survival would be represented by a negative slope, because most likely that's what's going to happen to you. You are going to die. So, hit the brakes.
So positive.
I am positive. I'm trying to tell you a life lesson here. If you see some trees, don't crank the gas and kill yourself. Next time you're driving and you see some trees, right? When you're driving and you see some trees and you slow down, I want you to think back to today and you can go, in your mind, you can say, man, you know what? Today, Wilson saved my life. What's up? She's driving into the trees.
What was she?
What if there's something important in the trees?
I don't know.
She crazy.
She's thinking why her son kept going, honey, Linda, honey. She's spacing out. I don't know.
Her choice to drive us to the tree.
But maybe you were trying to save
She's
Linda's life.
suicidal.
Linda, stop! Linda, we love you. Don't do it. Okay. 4, 3, 2, 1 on this section here. What we're going to be doing is we are going to be sketching a graph for a situation. So once again, the first thing we have to do is we have to read the situation, identify the slope or slopes we're talking about, and then relate it to the real world context. So if we read the situation here, it says, Miss Sutton provides free math tutoring to her students every day after school. No one comes to tutoring sessions during the first week of school. Over the next 2 weeks, use of the tutoring service gradually increases. So, that's the situation. We look at the first question that's being asked. Sketch a graph showing the number of students who use the tutoring service over the first 3 weeks of school. So I need the first 3 weeks. Go back to the situation. We see if we have that information. All right, so no one comes to tutoring sessions during the first week of school. Nobody's there. Nobody. Nobody. Over the next 2 weeks, this is going to be weeks 2 and 3, the use of tutoring gradually increases. That gives me enough information to graph this first question. So, service gradually increases, which means I can sketch a graph for weeks 1 through 3. So week 1, when I sketch the graph, what kind of slope does week 1 have? What kind of slope does week 1 have? A 0 slope. So from 0 to week 1, it's a 0 slope. No students showed up. Notice that students is my output, time is my input. So for the first week, nobody shows up. Over the next 2 weeks, what happens, Shimon? It increases what? A lot? Does it go like that? What's the word? What's the word in the situation? Shh, let him do it, please. It increases what? What underline right there? It increases gradually. So it's not going to be a really high, steep line. It's not going to be something like this. It's not even going to be something like this. We're looking for something that increases gradually. So I'd say a very small incline approaching week 3. Gradual increase. Gradual, not fast, slow. So we've done the first part. Next, Mrs. Sutton's students are told that they will have a math test at the end of the 5th week of school. How do you think this will affect the number of students who come to tutoring? So, if Mrs. Sutton is going to have a math test at the end of the 5th week, what do you think, Emily, is going to happen to the number of students that go to tutoring? It's going to increase. So if I was going to have a math test, you come to my tutoring?
Yeah.
What?
Yeah.
Okay, so yes, you would come because you need help. Corey wouldn't come because Corey's just cool like that. He got it. He said he don't need it. He coming in here just pumping out them 100s, bam, 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 one after the other. But it would go up, and I'd say it's probably going to go up rather quickly because students want to score well on an exam. So I'd say it's going to start going up exponentially. It's going to increase rather quickly. Increase, instead of gradual, I'd say that it's going to increase rapidly. It's a rapid increase. I don't know what kind of writing that is. Rapidly. It looks like rapidly. Okay, it's going to increase rapidly. That works for me. And then the last part, considering your answer to B, Corey's going to help me here. Considering your answer to B, Corey, I want you to sketch a graph showing the number of students who might use the tutoring service over the first 6 weeks of school. So we've done the first 5 weeks, right? We did week 1, nobody showed up. Weeks 1 to week 3, gradual. Weeks 3 to 5, big increase. What happens in week 5? And it flatlines, it goes down. You smell horrible. 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 And it goes straight down. So yeah, I mean, once the test is over, it's going to flatline. It's going to go straight down. There's not going to be anyone who wants to go to tutoring. So you're going to see a precipitous drop-off in the number of students who attend tutoring. So whereas precipitous, it's like precipitous, a precipice, a cliff. Precipitous means it's like jumping off a cliff. What happens when you jump off a cliff?
You
You
die.
fall directly down to the ground and you become a pile of goo.
Oh my god.
It's going to decrease, I'd say rapidly. You don't need to write precipitously. Decrease rapidly. A rapid decrease in the number of estudiantes who attend a tutoring session magnifico. Yes? Yes. Clearly,
Yes.
it's going to decrease rapidly. Alright, so,
Alright.
one last slide to go here. Now, this last scenario looks like we're presented with a table of data. And usually our graph's been done for us. Now in this case, is our graph completed for us?
No.
No, it is not. So we're actually going to have to go in and graph this information to see what this relationship looks like. So the data in the table shows the speed of a ride at an amusement park. This is going back to you kids out for summer. This is the roller coaster park that you went to right here. It looks like fun. There's also some water parks in there and stuff like that. This is the kiddie section. This might be where Matthew goes to, over there. Hangs out in the lazy river, okay? So we want to sketch a graph that shows the speed of the ride over time. We have our y-axis, which represents the output speed, and we have our x-axis, which represents the input time. The good thing is we have all of the coordinate pairs for us. All we have to do now is go in and graph this information. So what we'll do is we're going to go in, we're going to graph all this. Which one of these is my x? The time or the speed? Let's see if we remember. Time is my x, speed is my y. Okay, so the first one is going to be 320, 0. We go to the graph, we find 320, we find 0, and I put a point right there. Rather a big slim point, but whatever, it's still there. I need to graph the next point. What is the next point? Harashhan. Harashhan.
3, 20.
Well, no, it's 321, 14. The time is 321, then it's 14. That's the speed, all right? So we go to 321, we go up to 14 approximately, because it's, maybe a little off. There's 14, close enough. Okay, thank you, Sean. And then we're going to go to Miguel. All right, what's the next point that we got to graph?
322 to 41.
322 to 41, 322 up to 41, right about there. Okay, so we got that one, thank you. And then Corey, KG, are you with me? All right, well, help me out with this then. Corey, we need to graph the next point. What's the next point?
I'm thinking 62, 24.
No, it's 323, 62, x, y. So we go to 323, we go up to 62, which is right about there, and we have our point. Okay. How about with the next one? What's the next one now?
24 or
324,
324, 8.
all right, so we go to 324, we go up to 8, which is right about here, and we have that point. And then we have one more point. Let's go again to Corey. Corey, where's that going to be?
It's going to be at 0.
325, 0. So I have all my points graphed. Now I just have to connect those points with a what, guys?
Line.
With a Lizzie line. So I connect them with a line, and this makes sense given the situation because a roller coaster goes fast, and then it begins to slow down as you approach the end of the ride. So now that we've graphed it, we have to answer a couple questions. Between which time is the ride's speed increasing the fastest? So I need the 2 times that it's increasing the fastest. Let's go to Santana. What times?
320, and you can go to 323.
No, it's just 2 times. So here, 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 here,
Oh,
or
okay.
here. What times?
Alright,
Narrow it down. Narrow down the scope of the problem.
increasing the fastest, it's 321 and 322.
Perfect. 321 to 322, it increases by 27 miles per hour. And 27 miles per hour. It increases by 27 miles per hour between 321 and 322.
There's a ghost here. Wilson, why is there like Chinese words?
Oh, because I'll show you in a second. This is actually an amusement park from Japan where I found the map. All right, Miss Lama, last one. Between which times is the ride speed decreasing the fastest?
323 to 324.
323 to 324. So 323 to 324. It is decreasing the fastest, and it decreases, anybody know how much? 62 to 8. Anybody? Quick math?
62.
No?
8.
62 to 8. What's it
54.
decreasing by? 54. Who said that? Maria, good job. It's decreasing by 54 miles
That's a lot.
per hour. That's a quick slowdown there. So, a couple tickets here. Couple. Two. Maria. Two. The llama. Oh, I'm sorry. Just floated away from me. All right. Any questions on this? Seems pretty straightforward, right? Pretty easy. Seems pretty visual to me. All right. So.
Alright.
That's all for this time, campers. We invite you to tune in next time when we'll be talking about nuclear physics.
Wow.
Nuclear physics.
Yo, why you always wrong?
4, 3, 2, 1 on this.
All right. No.